Hi everyone, welcome back to my YouTube channel. So, in this video, we will be doing this question tapping rainwater, which is a hard problem on LeetCode. This problem is asked a lot in coding rounds and it is very important. So, in this video, we will be covering three approaches, that is brute force, first optimization, and most optimized approach. Okay, so let's read the question. Let n, given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water can be trapped after raining. So in this question, we have to find that how much these blue blocks are there. These blue blocks are the water that are stored in these black blocks that we have to find. For example, in this question, if we see, because the base is 1, that is why we only have to calculate the height. So, in this, it is 1, 2, 3, 4, 5, and 6. That is why the answer is 6, because if we fill more water here, then it will spill here. So, let's understand this question. And we have to find this total water that is stored. Okay, so let's start. For example, if we take that we want to store water at in this part, so we can fill it till here. It will not fall because 2 will take care of it. Then if we fill more, that is still here, it will be taken care of by this 3. Then if we fill more, then also it will not spill, because if it goes here, then it will be taken care of by this 4. Then if we go further, it will spill, because on the right hand side it is safe, this block will take care of it, but on here it no block is there to take care of, so this water will spill. So what we have to find exactly in this problem? For example, if we take example of this two, okay, so we can fill water till here, right? It will not fall because 3 will take care of it. And on the right hand side 5 is there, because it will fall, then 5 will take care of it. Then if we fill it till this, that is till this 4, then also it is fine. But what if I fill more than this 4? It will spill again. But on the right hand side 5 is there, but on the left hand side no one is there. So what we have to find from these two examples, are you getting an intuition that what we have to do exactly? We have to find that what is the maximum on the right hand side height that will take care of my water so that it will not fall, and what is the maximum height on the left hand side which will take care of. But on what it actually depends, that how much water will be stored. It depends on the minimum of these two, because if, for example, in this question we had 4 and 5, but although 5 was greater, but ultimately 4 was the deciding factor, because 4 was not large enough to handle this water. So what is the block of our which is our limiting block? It is 4, that is minimum of the maximum heights that we found. uh, in this question we found that the maximum height on the left hand side was 4, for this example I'm taking, and the right hand side's maximum height we found was 5. So for this one, if I see how much water is stored here in this block, this till here, can you see what it actually is? It is 4 minus my current height. That is, the minimum of these two was 4, right? Minimum of these two was 4. So 4 minus the current height. Current height was 0. So 4 was the water that was stored here. What if I take example of this 2? I will have to take left hand side is 4, right hand side is 5. The largest blocks I'm taking about. Then I have to subtract 4 and 2, that is 4, because it is the maximum I can store. And what I have to subtract? 2, the current block, because this block also occupies some space. I cannot store water here. So 4 minus 2, that is 2. So are you getting what we are actually doing? We are finding the maximum height on the left hand side as well as on the right hand side, because that actually decides how much water can be stored, and how much water will be spilled or not, that is decided by the minimum of these two, because that is the final deciding factor. So In short, what we have to do by now, till you must have understood that we are going to find the maximum element present. For example, if I take for this, I have to find the maximum element present in this, that is on the right hand side, maximum element present on the left hand side, and we will take the minimum of these two, and we will subtract our current element, that will give me the amount of water that is stored on the top. But what will happen on the top of the largest block? Nothing can be stored because no block is there on the left or the right hand side. So that is why the water will spill. So let's understand the brute force approach. What we are doing, we have to find the largest element on the left and the right. So what is the basic intuition we get? How will we do it? We will simply traverse through the complete array. Then for every element, we will traverse through the complete array. Then for every element, that is, for example, if I take this element, I will traverse to its left, find the maximum of these all in, that is, we found 2, and we will traverse to the right and find the maximum that is present in this part. What is the maximum? That is 5. Then we will take the minimum of 2 and 5. Minimum of 2 and 5, that is 2. And what we will do, we will subtract the current one, right? So how, what is the time complexity that you think here might be? It is O of n square, because we are traversing through the whole array. Then for every element we are again traversing through the whole array to find the left and the right maximums. That is why for brute force approach, the time complexity is O of n square. What is the space complexity? Space complexity is O of 1, because we are not using any space. But O of n square is not a good time complexity. So we need to optimize it. But how can we optimize it? O of n is for sure, because we have to traverse through the complete array. But can we reduce the time complexity for finding the left max and right max? Yes, that we can do for sure. But how? We can store it in a separate array, that is left and right array. What will left array store? It will store the maximum element it has seen till now. And what will the right element store? It will store moving from back, that the maximum element it has seen till now. So let's fill this vector or array. It will be 2, because maximum we have seen till now is 2. Then 2 and 0, if we compare, what is the maximum? 2. What if we compare 2 and 4? 4 is the new largest one. So it is 4. Then 4 and 0 if we compare, 4. 4 and 3 if we compare, 4. 4 and 2 if we compare, 4. 4 and 0 if we compare, 4. But now again we got 5, that is greater than 4. So we have to put 5. Yes. And after that all will be 5, because 5 was the largest one. Now for the right hand side, right vector, it will maintain the maximum element it has seen till now. So let's start. We will start from this 3. So it will be 3. Then if we compare 3 and this 1, it will be again 3. Then 3 and 2 if we compare, 3. 3 and 5 if we compare, yes, 5, because 5 is greater. Then 5 and these all will be 5, because 5 was the maximum element. So what do you think this the time complexity will be? Can you tell me? Try. What is the time complexity? Yes, O of n, because we have to traverse through the whole array, to traverse all the elements. But for every element we don't have to traverse again in the like the previous approach. We don't have to run 2 for loops to find the left max and right max. Why? Because we have already stored in this vector, and we just have to pick the elements, because we have already calculated this vector. We just have to pick. So the time complexity will be O of n. And what will be the space complexity? It will be O of, because we are occupying two vectors, two arrays of n size. So the space complexity will be O of n. But space complexity, I don't feel it's good, because time complexity is fine. Can we reduce the space complexity to O of 1 by any case so that our code is most optimized? Can you tell me how we can do this? How can we optimize the space complexity, because time complexity we got, that is O of n. Can you tell me how to reduce the space complexity? Instead of storing it in vector, can we calculate using some variables or something? Are you getting it? Have you heard of a two pointer approach? Two pointer approach. Yes, we will be doing it with two pointer approach. We will be storing in variables and we will manually find the maximum and the maximum elements on the left and on the right. We don't have to store it in a vector or an array, that is not in any left array or right array, and we don't have to run two for loops like brute force. It will be the most optimized approach. So what we have to do in this problem, we will we will take two pointers. One is here, second one is here. We will maintain a sum that will keep track of how much water have we added. Okay, so let's start. So we will also maintain a left max, that is the maximum element we found till now. We will also maintain a right max, that will maintain how much right max, that is we are moving from here, so how much maximum element we found till now. And when we move from here, L max, how much maximum element we found till now, that will be stored in this. And this is our left pointer, this is our right pointer. Right, so initially our left pointer is at here, right pointer is at here, so the left max is 2, right max is 3. Right. So what we have to do, I told you what we have to do. We have to calculate the minimum of these two. That is, for example, here it is 2 and minus. What will be our limiting block in these two? It will be 2. Yes. So we have to subtract our current one. I'm telling you that whichever is the minimum, that is on which we are, we have to subtract that from that. Okay, that the maximum we found till now, lm minimum of these two, and subtract the current one. Okay, so here it is 0. I'm just telling you the trick that if the two pointers are the same, that is the lm and rm are these two only, the answer will be always 0. You can calculate it also, it will always be 0. So let's start. First, our pointer is at here. It is 3. LM, RM, it is 2 and it is 3. So it will move forward. Now, left pointer will come here. Right? What is our current element? 0 now. And what is the minimum of these two? Because left is not updated. 0 is lesser. So, minimum of these two is 2. So, what is the answer? 2. Yes. So, let me add it to my sum. Now, since 0 is lesser than 3, so the pointer will move again forward. It will come here. So, what is our left max now? Our left max will be updated. Yes. Why will it be updated? Because 2 is lesser than 4. So, the new LM is 4. So, now, since we got the minimum of these two is 3, and it is 4, but since I told you that since they both 4 and 3 are what our pointers are, so the answer will be 0. We don't need to calculate it. So now let's move to another one. But what we will do now, since from minimum of these two, 4 and 3, 3 is the minimum one, 3 is the limiting block, so we don't have to move this 4 forward. Instead we have to move this 3 forward, because 3 was the limiting one. So then now this pointer comes to here, but our rm will not be updated because 1 is less than 3. So the current block is now 1. Here our sum was 2. Current block is 1 and we have to subtract, right? From what? From we will subtract the minimum of these two. What is the minimum? 3. So the answer will be 2, right? So we will add 2 as well. Now what we will do, we will move which pointer now, you tell me. since 4 and 1, what is the minimum one? 1. So we will move this for backward again. Now, what is the current element? 2. And what is the minimum? Since we are moving right, there is no effect on left one, and 3 will not be updated because 2 was less than 3, right? So now we have to subtract the minimum of 4 and 3, that is 3, from our current element, that is 2. So what is the answer? 1. So we have to add 1 as well. Now what we have to do, since we are at 2 and 4, again 2 is minimum, so it will move here, right? It will move to the 5 one. It will move to the fifth one. Now what we have to do, we have to let's write it again because it's lost. LM was 4 and RM was 3. LM was 4, RM was 3, and since I have come to a 5 block, this RM will be cut and it will now become 5. Why will it become 5? Because we have got a new maximum on right. That is why I got a 5. Now, what I have to do? I have to subtract the minimum of these two, that is 4. But it cannot be done. Why? Because 5 is already the largest block and no water can be stored in this because it will spill. Yes, that is why no water can be stored. Now, let's move forward fast. 4 and 5 pointers are there. Which is the minimum one? 4. So the pointer will move here. It will come here. Now, we are at current is 0. And what is the minimum of these two? What is the minimum of 4 and 5? 4. Yes. So how much water will be stored in this part? In this part, how much water will be stored? 4. Yes. So let's put add 4 as well to our sum. Now we have to move. Now we are on 0 and 5, which is the minimum one, 0. So it will move forward. Now pointer comes here. Now, uh, left one will not be updated because 3 is less and the maximums remain same. So, what we have to do, we have to subtract the current element, that is 3, from what? From our this minimum of that. So, it's 1. So, let's add it 1. Okay. Now, what we have to do? Since among 5 and 3, it will move forward. It will come here. Again, it will not be updated. What will be the answer? It will be 4 minus 2. So what will be the answer? 2. Yes. Again, among 2 and 5, who is lesser? 2. So 2 will move forward. It will come here. What will be the answer? 4 minus 0. That is 4. Right. So it will be 4. So what is my answer right now? If I calculate all these, what will be the answer? My answer will be 2 plus 2 plus 1, that is 5. 5 plus 5 will be 10. 10 plus 6, 16. So the answer will be 16 for this question. So now let's quickly see the code for this question. Right? Let's quickly see the code for this question. Yes. So in this question, I have taken the height, that is n in 10. Then in left 0, we have put it the left pointer as 0 and the right pointer as n minus 1. That is, they will be starting from the left and right, right? So that is why left pointer is here, right pointer is here. Then this is the store. This is storing the maximum values initially we have stored, and this is the answer that we have calculated, that is the sum what we have calculated here, it is the same, right? Then we will be running the while loop. Yes, one more thing, when the pointers will ultimately come here, after that they will be interchanged, that is right pointer comes here, left pointer comes here, so it will come out of our this while loop and our code will end. So it is the same thing, that what if my left one is left L max is lesser, that is L max is the limiting one, right? So I will have to increase it, right? And in the other case I will have to decrease the right one if the right one is greater, right? And in this part, I will have to add sum to what? To the minimum of these two, that was L max in this case, minus height of left, where I am currently. And why am I taking this max? Because what if it goes out of range? That is why I will have to take it for safety reasons. Then I will have to update the L max if I found a greater one, that is if I found a greater one on the left hand side. Then I have to do it same for the right hand side as well. Then I will have to return the sum. And this is a very easy solution. Please try to code it yourself. I will let's revise it again. So what we are taking, we are first taking pointers, then pointer is 0 and minus 1, then we are initializing the L max and R max as 0, then water initializing as 0, then we will run a while loop. Condition for the while loop is left is less than or equal to right. This is the pointer. Then we have two conditions. If the left max is less, second one, if the right max is less. So first, if L max is less, what we will do? I will add it to the sum, right? Water in, we will add it in water, and we will update the L max because we want, what if we don't do? We will be stuck there as zone only. And we also have to plus 1 the pointer, and the reverse is for the right case, and simply return water, and we are sorted. This is so easy solution. This is a hard problem on LeetCode, but it is actually very easy problem. So this was the solution. If you liked my video, please do subscribe, share, and support. Please tap on like button and subscribe. Thank you.